Mike Levin on Tuesday, July 12th, 2022. And I dropped my kid at Scout Camp on Sunday. And then I rested. And I could not bring myself to do one of these drives to the storage facility on Monday night because I still rested. Here I am on Tuesday night, the first night after the move, having had my kid with me for the week following the move. So this is my first night that I am not recuperating and nor hosting my kid. So it's my first opening to do a run and pick up from public storage. It's of devastating interest, I'm sure, to everyone out there. But this is my life. This is what I'm doing for a little while, and this will be the time when I have to talk. I will have a few more of these long drive times until I set into some new rhythm, hopefully more talking head stuff. That is its own motivational challenge because I really should do it before the workday begins or after the workday is over, which is exactly when my audience, the general audience, if I actually want people to start showing up, in decent numbers on a live cast is in the middle of the day, but no can do. So today, for example, I would have liked to have gotten back to the LXD stuff for work, right? It's ultimately for work that I'm doing all this, except some other deliverable stuff came up, and now that I have enough calories floating around in my head, because part of this is just the recovery. You get all the little aches and sores after a big move, and the stress of it, because also the cat disappeared. So it was kind of a double whammy, a triple whammy if you consider some other things. But life only dishes out as much as you're capable of handling. There's a lot of ways of looking at this. The fact you're still here, the fact that we're all still here, are some of the largest arguments ever to be made in existence, right? Because everything is relative to you, even if we live in an absolute world, and even if we are free of the plague of narcissism, thinking we're at the center of the world, we each still, from a viewport standpoint, are in fact at the center of our own observable universe. As my observable universe is slightly different from the truck driver up ahead of me, because the difference in our locations and the speed of light means that the sphere surrounding him, out of all light that will ever be observable to him or her, is different from me. I guess you have to take our lifespans into account too in calculating the observable universe. There's a fuzzy boundary where an estimation must be made on the average human lifespan. So even the boundaries of a observable universe are probabilistic or statistical in nature. Probability clouds. There's a lot in reality which is actually more like clouds of probability than an actual physical manifestation of an object in a place. It is arguable that there are no, this material world, this physical world we're always talking about, is just standing waveforms that have learned the trick of appearing to be solid by clumping together, something like that. carbon 32 or something. When 32 carbons link up into a soccer ball, or it might be 64, something along those lines. That macro construct, right? It's not just a single carbon atom. It's a stable carbon bond, where every possible outer valence electron bond of a carbon atom is bonded to another carbon, because carbon has exactly 4 to contribute or 4 to receive. It's balanced in the vibrating edge of the elements, which makes it, is it a stable, bound to it itself, sort of almost noble element, or is it highly chemically reactive, wanting to bond to everything that comes near it, like a corrosive or a poison, like chlorine. I believe it's chloride. Anyway, it's, has I believe, an electron to contribute all the time, and always wants to be bound to things. So when it's sodium, the metal sodium, you get sodium chloride and you get common table salt, and then whatever was highly chemically reactive suddenly becomes inert. It becomes, just happy to sit there and taste like a salt. So similar things happen with carbon. Carbon lives right between solid and gas. And when it's a solid, it can be one of the hardest elements, one of the hardest things in existence, diamond. And when it's gas, well, it's usually bound with something else, carbon, CO2, carbon dioxide, carbon monoxide. And those are, in fact, the greenhouse gases, right? So them being up in the atmosphere, I believe, eats away at the ozone, because it gobbles up the oxygen, which is otherwise bound in O3, ozone, which blocks radiation, there's all kinds of stuff there. It's not good for the environment. Too much carbon released into the air. So the whole concept that the Earth is a living, breathing thing, the Earth breathes through the seasons and such. You can see close analogies to actual, breathing in and breathing out. The same is true with the absorption and release of water. And carbon is another thing like that. Carbon is oftentimes released into the atmosphere from eras of super volcanoes and stuff like that. It happens. And then the carbon gets tied up onto the surface of the Earth again through scale trees. Scale trees is what most of our oil comes from today. There was some epoch that was mostly plants, not a lot of animals. And of the plants, it was mostly scale trees, which were just basically like a whole bunch of telephone poles with branches coming out at right angles, and I guess leaves at the end of the branches. So it wasn't a very fractally, tree like we have today, with lots of zigzags and, branches and, smaller structures resembling the bigger structures. If that fractal arrangement existed in scale trees, the fractal was a right angle, not very exciting. So, sticks, branches stuck out at right angles from these telephone pole-like trees. And then, the leaves stuck out at right angles from the sticks. So it wasn't a very good strategy for creating lots of canopy coverage, nor for being very strong, because when these things toppled, they apparently toppled en masse. And then you got mats and mats of scale trees. And And they call them scale trees because the surface of it, all these pock marks where branches could reach out from, look like scales covering the tree more than bark, so scale trees. And that is a decent example of the purpose of life, which seems to be to overcome the inherent randomization of things, the constant movement towards disorder from order. It's one of the laws of thermodynamics. I have to get my numbers right, but it might be the third law of thermodynamics. If it's not, it's the second law of thermodynamics. And it's basically things tend to move from a more ordered state to a less ordered state, and heat is released as a byproduct. And almost all systems release heat. And in the release of that heat, member components of the system, which were moving around with more kinetic energy because that heat was a part of it, slow down, and they move around with less kinetic energy. They bounce against each other less often, and all the rest. Which is where the concept of the heat death of the universe comes from, because after a while, all the energy that's inherent in particles will be released, and those particles will settle down into non-movement, coldness, evenly dispersed. Things will bump against each other and spread out. And the heat, which is information as well, goes to we know not where, right? It's released, but information, heat, is neither, it's not destroyed. It goes somewhere. It becomes less ordered, so the information is less information-y when it becomes heat. But it's not gone. It becomes part of the ambient background radiation, or perhaps blends into quantum foam, because the only difference between virtual particles that are popping in and out of existence all around us because of ripply waving membranes, and as those membranes ripple, when the energy peaks reach a certain point or whatnot, they look like particles. They look a lot like photons or electrons to us. And every once in a while, I'm told they're protons and neutrons as well. They all more persistent particles are represented amongst the virtual particles. However, in the greatest magnitude, I believe, the equivalent of photons are popping in and out of existence. And for that membrane to be rippling, for the quantum membrane to ripple, one would presume that there's energy going into it from somewhere. So at least part of this is all that heat energy that's getting lost from all other things might just be contributing to, background white noise energy that's all around us. Anyway, life goes in the opposite direction. Instead of allowing all that heat energy to go out into the quantum foam and to dissipate into nothingness all around us, life steals that little bit of energy and builds the bonds and creates the less probable, less likely construct, physical construct out of little bits of matter. Usually atoms by this time, but it is worth noting that what we call quarks, that constitute a lot of the physical matter of our universe, because it's what protons and neutrons are both made out of, the heavy center of atoms, except all we ever interact with or touch is electron fields. We only interact with fields. We never really touch the things that have the heavier atomic weight, the protons, the neutrons. Yet things are built out of the protons and neutrons based on how they stick together, based on the electron fields that they're capable of producing, the open spots in the different spheres around the proton and neutron. So it has this lower sphere, which is the first valence level, which I think only 2 electrons can occupy, and then above that it might be 4, something like that. I forget exactly how it works, but they link together like little Legos, and if they don't, it's generally 1 proton maybe hanging out with 1 neutron, and you've got hydrogen. Atomic weights of approximately 2, atomic number of 1, because it's got 1 proton, and the number of protons is the atomic number. The number of protons and neutrons is roughly the atomic weight, but never exactly, because of all these nuanced details of particle decay. Things are made of tinier things, and eventually neutrons will just shoot off because they're not bound to the nucleus that tightly. That's alpha particle decay. That is a form of radiation, the most dangerous, because it's heavy, elements. It's not one of the heavy elements, but it is a element that's knocking into you, which, whoa, holy shit. Someone was coming up the wrong way. Oh my God. Someone was coming up the wrong way on the highway and straight at me. I did some fancy driving maneuvering, and everything was fine. But that person was in danger. Do I keep this friggin' video? So just to be clear, there was an island between us, and at some point there was a way for the person to cut over to the other side of the island, probably right at the Easy Pass toll booth. So that person pulled through an Easy Path lane and zagged so that they were coming head on with highway traffic in the opposite direction. I was in the leftmost lane because I like to go through on the left of these things, of these Easy Pass things, because they're usually the fully automated ones to the left. So he was coming right at me, and I saw it, so I changed lanes. He went past me. It was a weird experience. I wish that person well. Whew. So, this would be an appropriate time to bring up how systems back up systems back up systems. So everything's a system. All of life, what we know to the best of our ability as the standard model, plus information, plus gravity, great big system, the system of all we know. And there are lots of subsystems within that. Subsystems of things on usually different scales. You would break it up by scale. So within system of all that exists that we know. There are subsystems such as, solar, solar regions, solar systems. Solar systems are called systems. So usually there's a sun, maybe two, and a series of planets orbiting around the suns, and some of the planets might have moons, and there's usually some sort of asteroid belt, debris belt, some variety of gas giants, and Earth-like planets. I should say Earth size, because they're not necessarily Earth-like. And all the common ingredients somehow or other get there. The theories of how that works exactly does vary. There's the belief that there are subsequent explosions in a solar system. The first one creates the heavy metals. And there might only just be the one. That would be, I guess, the single clap, After the first clap, you've got heavy metals. And then the next death of the sun is going to be to some brown dwarf or something like that. Cold, a red dwarf, brown, it burns out. The fuel burns out. Maybe there's a residual, something there. Black hole eventually, maybe, I don't know. Black holes seem to be the ultimate recycling of matter into its information components, because of the event horizon of no escape of all things into a black hole, a singularity. And then the discovery of Hawking radiation, that black holes are not so black after all. If you look at it in the correct spectrum, you will see it's radiating off energy, at least heat energy, because of quantum effects, because things don't have exact locations. So once they go over the once they go over the event horizon, the point of no return of the boundary of a black hole, the same thing that results in quantum tunneling can happen, and then the particle is just magically outside the event horizon again. And then it somehow can go the opposite direction. Don't ask me how. You would think it would curve right back and it would be caught in turn. However, black holes appear to radiate heat. They appear to be hot. And so that's just another path to the heat death of the universe. If everything disperses through disintegration and goes off like vapors, you've got heat death in one direction by things ultimately becoming hydrogen. And then if it goes the other direction and clumps up into small, tight clumps of black holes, it eventually gets radiated out as heat energy again. And you have, it's not even the same thing, because gone are your hydrogen atoms. Just energy goes out. Heat, pure heat energy with nothing to go into, apparently. I'm not exactly sure how that works. Does it need a substrate? Heat is always confusing too, because the ability to see heat in the infrared part of the spectrum made me always think that, well, heat is just one special part of the electromagnetic spectrum. But it does turn out to be that heat is this other general escaping of energy, from one of the laws of thermodynamics. And it's not always in particular from the heat part of the electromagnetic spectrum. It's any energy emission, any light or energy emission is, quote, heat. There is a warmth to it or something. There's energy in it, so it's heat. But it's really anything on the electromagnetic spectrum, right? So the emission of any sort of photons. So is heat the emission of photons? Is true heat, what is the connection between information, heat information? Because, the connection is always made between heat and information. But is there a connection between a unit of heat information and light? Because that would make total sense. It would be an indication of popping us back into a sensible, thunkable, binary universe. Things are black and white. There's a photon. It's either has a quantized energy state or it doesn't. There's the smallest wavelength of a photon too, which is very tempting to think of as a pixel element of the universe, because E equals mc squared, so all matter is energy. That energy is, fill in the blank of your electromagnetic spectrum. Or you can be reductionist about it and say everything that's divisible by a smallest wavelength is derivative of that wavelength. So there could be a smallest, a smallest particle or element. It's hard to even use the words particle or element. It's a ripple size in the quantum foam. The smallest a ripple can be in the quantum foam seems to be approximately 1 photon. And the smallest wavelength of a photon. Now, we're in the neighborhood of this thing called the Planck unit. Now, I'm not sure if 1 photon is 1 Planck unit, but 1 Planck unit is the theoretic smallest black hole possible, right? So the physics of a black hole says a black hole can get this small and then it can't get any smaller. And that seems to be, I've been led to believe from these Max Tegmark mathematical universe books and stuff, that's in the neighborhood of a photon. Smallest wavelength of a photon, and that is indeed very tiny. Photons, by the way they relate to the other particles, if you will, is electrons can bounce between different energy states orbiting a nucleus of an atom. So they can pop from the lower shell to the upper shell, given how much energy is in the electron from what? A photon. So an electron can absorb a photon and jump to a higher energy state. The electron can then jump down to the lower energy state and release and emit that photon. And I believe, if I have it right, I forget the different names of these element types, leptons and stuff like that, but one of these types, I think it's a type that photons are a member of, you can have a lot of them in the same space. Potentially unlimited, which seems nuts because you can double up energy into the same location, it seems, so that tricks like resonance can be amped up to potentially unlimited levels, which just seems a little bit insane. But these tricks are used in amplifier systems and, lasers, coherent light. So it's not total BS, but other things cannot occupy the same space. You can't put unlimited protons and neutrons. They, clump up into balls as opposed to pack infinitely into the same space like photons seem to be able to do. Then there's also the question of electrons. Well, electrons are interesting because from all the math surrounding it, there might be one electron in the entire universe, and it's the same electron everywhere. There's no variation in electrons. There's whether that electron of that I don't even know how to describe it actually, but electrons have been described as they're potentially being one in the entire universe, and it's where it is changes based on whether it's absorbed or emitted photons, so that they can host photons inside of it. Electrons can be like, hey photon, come on and hang with me for a while. Aside from some electron microscopy or something like that, I forget the exact word for it, but we use electrons to do imaging because you can blow up a lens effect to much larger, so we can somewhat visualize atoms, protons, and neutrons using electrons. Visualizing electrons is a lot harder, and then visualizing photons harder still. I don't know if science has the experiments to visualize photons yet. What would you use? Theoretically, there's smaller particles you could use. You could use photons to attempt to image an electron, I assume, except that electrons absorb photons, so there's that. But it's their behavior and appearance are elusive to thinking on the human scale. We are extremely derivative computers. We are not first order pure logic computers, which would be somehow tied to the universe, how the universe really exists. The fact that the universe can support life such as us means that there's a super system by which we all abide, right? We're buying into the rules that set out by some set of universal constants. All the dials set just so that our universe can exist the way it does, so that things clump up the way they do. And they clump up on different interesting levels. They clump up on the atomic levels to create atoms out of what must be whole universes of smaller particles, right? Because there's probably as many, if E equals mc squared and all solid matter is made from energy, and energy at its smallest is the smallest wavelength of light, one photon, smallest wavelength of a photon. So we're all probably made up of that smallest wavelength of a photon, just clumped together in lots of different creative ways. As many of those photons in a proton as there are protons in a universe? Could it be that much of a, order, like there's as many particles inside each atom as there are the larger particles we think of as atoms inside our universe. If that's the case, it really implies the nestedness that could be going on here, very easily creating infinite space for things, because does scale really matter? Can you have a universe just as interesting as us, with all the same physical attributes of gravity, have universes within an atom, within a single atom? You know, it's a recurring image in sci-fi. Men in Black popularized it. But the idea is reoccurring. There are certainly different dimension-like things, and you get one of them just by looking at scale. If the universe is infinite, you got one of them, because infinite space is actually an awful lot of space. So much so that Rick and Morty stuff starts to become, feasible. Universes where almost everything is the same except for some little detail, and then the questions regarding human will, because are all the decisions being made according to some predestined algorithm that existed at the moment? Time itself is an illusion. Time is derivative. We're derivative. Time is derivative. Intelligence is derivative. What we call our sentience is derivative. It's derived from bigger soupy mixes of things that abide by the same set of rules. That's nuts. That's nuts. Of course, reality is a video game, but it's not in the dystopian way, the nihilistic way that so many people invoke that concept. What is the difference between a virtual world and a non-virtual world? I came to grips with this same concept I was struggling with, what are these virtual particles? Where are they coming from and where are they going to? Is it a magic fourth spatial dimension? Is it proof of a fourth spatial dimension, like Tesseract-like stuff? Or is it, as it turns out, just when energy levels go over a certain level in the space that's already there, and it becomes a seeming material? So you've got a substrate. You've got a substrate of stuff. It's the quantum substrate. And not until there's a ping, not until there's a quantum of energy plinged into it, is there movement of any kind. And without movement of any kind, you don't have physical matter coming into existence, right? So, when the quantum substrate ripples, you've got particles popping into existence. The rippling is what creates the particle-iness. But then they go away as quickly as the ripples dissipate, just like a pling on the surface of a pond when it's drizzling. That's the quantum particles, because there's never enough energy for them to stabilize and become persistent. It would seem, and I'm no particle physicist or anything, but it would seem to me that persistence is just a matter of more cohesion, more energy, more stuff. Thus, more energy. Always about more energy. Things going in the form of what we would imagine is light, right? You shine a flashlight at something. Now this thing you're shining the flashlight of is made of particles because you're shining the flashlight. And these particles are starting to ripple around because now they have some heat energy that can be kinetic, and they can bump into each other, and then they can dissipate off the same energy that was shown into them. And that energy could keep spreading out and becoming more dispersed through osmosis and evening out. That rule of thermodynamics thing. Until it settles down to a state like the energy, like the flashlight was never even shown into it in the first place, such as the infinite ability to dissipate energy over time, right? Just the way things like folding can have tremendous effects of, with such a simple thing as folding and folding again. Bifurcation can create all kinds of machinery because it's so cool. Nano-fabricated things in the protein folding process. Folding is cool. A underexplained magical characteristic of the physical world. So we carry on. Persistence. Persistence is always an issue. Without persistence, things lose state, and no matter how good the system is built, no matter how good the components of your system are, without an easy breezy way to link them together and then to have memory for those linkages to not go away. These are the earliest things leading to in engineering and computer design. It would have been the separation of storage media from dynamic random access memory. So, dynamic random access memory would have been something like a mechanical relay. You put some energy into something, a solenoid, and because that solenoid is magnetic, it can pull down the lever of a switch. And that's a state. That state, I guess, would be called on, because power is being applied. Energy is flowing through the circuit is on. Because the circuit is on, a magnetic field exists in the solenoid. That magnetic field has the ability to pull down on a switch, a lever switch, and perhaps a connection is broken up here, reversing its logic. The current can be going either through the switch and a contact being made, or a contact that was previously made could be broken by the throwing of the switch. So some previous flow could be getting turned on or off. That is dynamic RAM. It only lasts for as long as the power is being applied. You remove the power, click, all the relays go to their natural off state positions. So it is not immediately inherently obvious that a system has responsibility for how a program runs at the moment it's being used versus how the usually output of a system persists after the answer is calculated and no longer needs to be in dynamic RAM. It can be offloaded. That document can be saved and put elsewhere in a place where less energy is needed to keep it state. In fact, more energy goes into acquiring its state, you see. So that no energy is required in maintaining its state. And that would be like a flash drive or a thumb drive or an SSD, a solid state drive. More and more frequently, we are finding, rows and columns of transistors to be a more effective storage media than a spinning platter. So spinning platters are very mechanical. They're not eliminating some very mechanical bits. Spinning of a platter, so you got maximum speeds, maximum read-write times based on the limitations of mechanical spinning, a spindle arrangement, literally like a top, like a child's toy. And that's what all hard drives are. Anything that's a traditional hard drive has spinning plates in there. And then those spinning plates have little magnetic pits. It's got some substrate, which is, an alloy. It's a combination of things. You'll call it, magnetic crystals or something. So that with enough force, you can move a crystal, something like you can think of liquid crystals of liquid crystal displays. They can be yanked and pulled around. They've got some physical resistance to them. This is why USB keychain drives heat up when you copy a lot of stuff over to them. That's a lot of physical energy being put into giving those switches a state that will stay that way even when power is removed and that thing is dangling from your keychain. Why isn't all memory of this type that is still there when the computer is turned off? Because it would be too slow to calculate, and it would be too hot to the touch, and it would wear out too fast to the economies. That would be called universal memory, and we're not there yet. We simulate universal memory really good with, caches that are made from solid state drives, from SSDs. So these are, those caches that speed things up so much that you hear of all the time, because your disks don't have to spin so much if you just put the most accessed things onto solid state SSD type technology. Something living halfway between a flash drive and the dream of universal memory. It's not quite universal memory because you gotta leave some low power. This is the reasons our computers go to sleep and hibernate, but rarely really ever turn off. A hard power cycle is a rare thing these days, especially on laptops. UNIX is always in control. So back in the day, back in the 90s, the early 90s, when Linux was being conceived of and released in its first versions for 386 computers, there was a debate between the legendary Linus Torvalds and the less legendary but should be known Andrew Tannenbaum. So Linux was inspired by Linus Torvalds having to learn the Minix operating system, MINIX OS operating systems, Minix OS, as an educational version of Unix that everyone could afford and run on their 386 or whatever hardware. It's just, it wasn't very built up. It was extremely minimal. And it wasn't enough, apparently, to run a full desktop computer. But it inspired Linus Torvalds to say, hey, maybe I'll do this as a summer project. And in following conversations, because Linus was very vocal online, I guess these were the use groups of the day. They're not around so much anymore. Use groups and news groups have mostly gone away. They've been absorbed into like Google groups and stuff like that. I guess there's still some internet relay chat, IRC, around. But, wow, that must be really some interesting underground stuff. I ought to look into IRC. Slack has basically made its fortune on bringing back the concept of internet relay chat groups. But there were also news groups and discussion forums. And that's where people hung out back in those days, having little wars. And one of the wars was between Linus Torvalds and Andrew Tannenbaum, with Andrew advocating a microkernel design, which I guess is reminiscent of web services of today. A clear delineation of part responsibilities between parts of a system, the subsystem. Strong lines dividing the subsystems of a system. Things are loosely coupled. They don't know about each other's internals, and they have to abide by formal APIs and talking to each other. With this comes the ability to update components in potentially real time, to have systems that are just forever improving by having the I/O components or the processing components or whatever bits just continuously upgraded in modular, hush for a moment while I replace you, Lego-like chunks. That's microkernel design, and that's Andrew Tannenbaum, and that's UNIX. Linus Torvalds' approach was what they would call a monolithic design with tightly coupled components. Things under the hood were allowed to know about each other. Things could hit the metal so long as the things hitting the metal were allowed to, by some set of rules about when you could tightly couple things in Linux, in its kernel, the Linux kernel, for performance benefits, security benefits, security performance. Those are probably the two main things. You can get benefits in how secure things are by tweaking the way they work at the most fundamental level, and you can get benefits in performance in tweaking how things work at the most fundamental level, meaning grabbing efficiencies that would be made inaccessible through formal APIs that you must go through. This is why Android things multitask better, and why Android stuff runs in the background more cleanly, and why Android stuff can be spyware more easily and use up your battery more quickly. Android doesn't tightly regulate this nearly as much as iOS and Apple, because Steve Jobs, being the control freak that he was, saw iOS as an opportunity to put an end to the chapter of computer viruses and Trojans by a tightly regulated ecosystem of software with isolation layers at the system level, at the user level, and indeed down to the very app level, which is what we see today more frequently on the desktop and server technology side as containerization. But this containerization was certainly expressed in a spiritually connected sandbox concept. So containerization and sandboxing a thing are spiritually very closely tied together. Not entirely, because a shared kernel is a shared kernel, and there's risk there. It's not the level of isolation you would get in, say, a virtual machine, but it's much higher performance. And you can treat it just like a virtual machine with higher performance and greater stability. And that is the big promise of so many things these days. An isolation layer that works just like a container. And being in the middle of a move again, going back and forth to a public container facility to get the necessary things per the 80-20 rule through a limited bus, how much I can fit in the car on this drive back and forth, where I do use up some gas, burn some carbon, release that into the atmosphere. Not great. It's a little bit rainy and drizzly, so it's not going to be ideal weather for doing this either. But this is what we would call in the business manning up. I chose to make the move out of that house as painless as possible by gradually moving stuff over into public storage, so I didn't have to really specifically load stuff up into boxes. I hate that extra level of containerization. I hate making things inaccessible at that personal level. I'm a big fan of clear boxes. I'm a big fan of sorting trays. I'm a big fan of not putting lids back on things, but having things clear boxed in an easily accessible shelving system, so that things can always be shuffled around and stuff tends to be known. You know where your stuff is, and shuffleable to a more usable state constantly, so that over time things get forever more organized. There's some downsides and pitfalls. I'm going to be accumulating up junk I want to get rid of left over at the other side. So long as I keep residency over there, my ID shows it, I will be able to take advantage of their spring cleanup day, although that's once a year, where I can take a carload of stuff over for $20. That would mean keeping this place for a year. That's $250 a month. I don't know if I want to do that. Whereas if I could empty it out down to the junk quickly and then just hire a junk remover to come in and pick up all the stuff. That's the way to do it. Because the last thing I want to do is, after I pull out all my stuff and I have it accumulated down to the stuff I want to get rid of, the last thing I want to do is have to load all that stuff up and take it again somewhere on some special day that's a year away, or to find out how to do a dump. You can't just drive stuff to a dump like you used to be able to. The recycling centers seem to be closed or, not working the way they used to. So it's a challenge to get rid of stuff. So you use local businesses that remove junk. It's what they do. They find ways to make money off your junk. They'll resell what can be resold. So they make money both ways. They get paid to pick up your junk, and then they get paid sorting your junk out to other things. There's economies in everything if you just know how to connect the dots. So I will be connecting the dots between me and a junk remover. Coming the other way, there is a pile up. Whew. That's cleared out by my return. I am sure it will be. These are interesting videos, and the closing round of a chapter, really, of my life. The Pocono's chapter. It was a good chapter. It had a lot of really strong points. I did not think I was going to be having another chapter back on this particular place that I'm at now, but I am, and so be it. We do what we have to do in life. It is a constant adventure. Sure, reveal, you probably have seen it already or inferred what it was. We are always on a campaign. We are always thinking about provisioning ourselves. We are always thinking about stylizing our character, making our character an individual. This is not narcissism. This is self-awareness. Self-awareness from a place of excess, because we're doing it while driving, being at the peak of our game on multiple fronts at once, being able to cognitively think things through out loud, talking to oneself, journaling is essentially what I'm doing. When I'm talking to you, my YouTube audience, my friends, especially in situations like this where I just really don't care about the audio quality. What am I going to set microphones up for this? All I really care about is bare minimal quality, you know? Someday maybe AIs clean up. I should bookmark things, tag things with words, because all words will be parsed. Underscore AI, look here. Underscore idea. So the problem with underscores, even though they have the advantage of being seen as part of the word on repeat search feature in Vim, so it's very nice to hover your cursor over a word and hit Shift 8 for find next. Now the thing is, the word boundaries for find next will include an underscore with it, which makes it a perfect tagging symbol. So if you want uniqueness in something, you would do underscore idea, and you just say underscore idea wherever you want that tag dropped, you know, talking through a video, or as you're typing in Vim, you would type it. Now the problem is that is also, that has meaning as markdown. The very popular, notes to formatted website language. It's language. It's a very minimal syntax to mark up your text for good visual display. So it's a play on words. Instead of marking up your text, you're marking down your text. It's marked down. And there were things like it before it, but this is the one that caught on for whatever reasons. And so everyone's sort of abiding by it and rendering things that have a .md extension. So my journals all have a .md extension, so the tags that I want to use have markdown meaning, and it starts italicizing everything that follows. I have to resolve that. And these are the things I'm going to talk about on videos like this after we're an hour in. So we're an hour and 4 minutes, and I'll probably talk right up until the public storage place. And you'll see me going into the misty mountains. You'll see the misty mountains scroll by my side window. And this trip is a wonderful example of sentience and human free will. I have to make a certain number of trips to empty out this public storage as soon as possible to get rid of this expense. I am doing this because I did not hire a moving truck. This is an alternative to a moving truck. And because moving trucks dump everything on you in your living quarters, bam, and it verklemps you. It slams you up, it jams you up, it puts too much, makes you bite off more than you can chew. I don't like it. I hate it. I have had the hunger to digest and to get organized or whatever for some time now. That organization that I'm talking about, with like how all your trash goes to work, someone will charge you for hauling away your junk, and then they'll make further money on breaking up your junk and selling it to different places, maybe flea markets and stuff like that, or to recycling centers who actually want the good pre-sorted stuff, whatever. However they sort it out, they make more money on you. You're doing something like that in your own realm, in your own problem domain, because life's too short to sort junk and to sell it on eBay and to make gift packages. Maybe I'll do some. Maybe I'll start a giveaway. I'll be a little bit like the Beast and put together care packages if people would be interested. I got stuff to get rid of. And if you would just pay the shipping and handling, maybe I would have it so that you would Venmo me, $20, and I'll ship a box of stuff to you. And I got a lot of interesting stuff, let me tell you. So maybe it's time to ship interesting boxes of stuff to people. Do that in recycling. Do the environmentally conscious thing. There is no trash. There's just other people's raw materials. So it's a matter of getting things places. So generalized robots will be useful just for their capacity of sorting and moving. Sorting and for their sorting and skidders, sort and skidders. So the Bobiverse had some very wonderful renditions of these things. They might have been called manipulators, something to that effect, but they were like 3 short, stubby octopus tentacles, but mechanical in nature, with high degrees of freedom, maneuverability. It's not like the joint maneuverability. It's the whole thing could move like an octopus limb. So it must have been highly programmable into different configurations and behaviors. The ability to walk is like some sort of tripod beast, and the ability to create vice-like situations, to prop things up, to pinch things between 2 pinchers while having a third thing free for mobility purposes or positioning purposes. So 3 would probably be the minimal, but you let things have their little octopus tentacle spider legs, and then you got a general purpose sorting and scurrying thing, and life improves in unlimited ways because these are generalized hardware, just for the same way software can be generalized, hardware cannot. Hardware currently is either turned into a wheeled vehicle, a computer, a wheeled vehicle with a computer, but very precise, pre-configured arrangements of matter. Highly designed, tightly coupled, monolithic designs, Linus Torvalds, Linuxy. So that brings us full circle to Linus Torvalds' argument that when things talk to each other under the hood, They can purr like a kitten. You can have a well-tuned engine. It will perform well. And it's a better user experience. Sometimes you allow things to hit the metal under the hood so that the user experience is better, faster, tighter, smoother. Andrew Tannenbaum, the creator of UNIX, did not agree. He was like, no, you really have to separate these things down here at this low level so that no parts of your system are overly reliant on other parts of your system. You don't want it so that the whole thing goes down or the whole thing is working. You want bits of your system to be able to hang on and have self-healing capability, you know, more lifelike systems. And so UNIX seems to have gone away. And if you're an hour and 11 minutes into this video with me, then you deserve to get to the little bit of paranoid rambling. UNIX never went away. UNIX just got built into your CPUs. Everything since something like Sandy Beach, Sandy something, 2007, 2008 generation Intel, called the Intel Management Engine, IME, I believe it's called. It's a shadow operating system. It's a full-fledged version of UNIX called UNIX 5 running on your computer, even when it's asleep. The UNIX part is low power awake. That is what's managing the resources of your system. That's what's keeping enough power to get to a cached, SSD-like system so that it can feel like universal memory when it isn't. So you need a certain amount of always on, always aware, and it has its own network stack. I believe it has its own MAC address. So you can find it on the network, I believe. Now, people correct me if I'm wrong, but if you're running Wireshark or things like that, you should be able to detect the network existence of this version of UNIX running on your machine. It's a backdoor, my friends. It keeps your machine running well. Did you notice that, the idea of a computer being asleep and being awake, on and off, has suddenly disappeared as if we had universal memory? It's as if that breakthrough was made, but that breakthrough was never made. There's something mitigating all this, which is much less super high-tech than universal memory. It is another computer, another low-power computer system. What is that low-power computer system? Well, it's UNIX 5. It's a version of UNIX, a direct descendant of the same UNIX that Andrew Tannenbaum created and debated with Linus Torvalds in 1990, 91, 92 on these Usenet forums, on these discussion groups. And you can Google these things up. They're still archived. They're part of history. And ultimately, there is probably more versions of UNIX deployed. There are more people unknowingly using UNIX through the UNIX route than there are people unknowingly using Linux through the what route? Through Android. A lot of people, but most people running Android know that they're running Linux, at least the boot kernel, which gets into other issues. I don't have a lot of time before I'm at the storage facility, but a lot of this discussion really is about how portable the C components are between Unix-like operating systems, so that everything you do, including your Python work, is cross-platform, that you live and work in a vendor-independent fashion, that you do not really rely on Microsoft, even though you will be using Microsoft tools, no doubt. If you're keeping your Git repositories on GitHub, you're using Microsoft product. If you're doing that $80 or $100 a year subscription for developers so you can have unlimited free private repos that you can collaborate with people on without the limits, then you're paying a Microsoft tax every year, $100 Microsoft developer tax. All developers must pay and thus be known to Microsoft because they bought GitHub, right? So you're not getting away from Microsoft. And GitHub is going to have these inline IDE features sprinkled all over the place over the next year or two. It's called GitHub Code Spaces, Git Spaces, GitHub Spaces. But basically, embedded VS Code. You know VS Code that a lot of you are running on your desktop as an Electron app, as your text editor, as your Atom replacement, as your Sublime replacement, as your Notepad++ replacement, as your Visual Studio.net replacement, as your Xcode replacement. Should I go on? Because I could. As your PFE replacement, as your text edit replacement. Did I say that one already? Starting to go old school on Macintosh. Cygnus editor on the Amiga as your CED replacement. Okay, so anyway, there are many moving parts in tech. UNIX is usually not one of them. Linux, sometimes a little bit more so. The systemd stuff I'm advocating is a Linux trick, not really so much a Unix trick. Although it was lifted from work done by Apple on the Darwin distro, the Apple-sponsored Darwin distro of Unix, a BSD derivative that no one really uses. However, something there was copied and it became systemd. Systemd is a monolithic, just like the Linux kernel itself. The Linux kernel does not abide by the Unix way. Linux itself is in your face with the Unix way. Much of what rocks about NIX operating systems is the Unix way that comes from a set of beliefs that was articulated by Ken Thompson, but which existed in prior scrambled state and form throughout Bell Atlantic, I guess, Ma Bell research laboratories. I forget the town in New Jersey. Oh my God. But a little town in New Jersey where all this stuff was going on, and then some honorable mention other places, which usually includes MIT, and actually includes some part of England where BCPL was created, because everything that became what we know as Dennis Ritchie C was inspired by a British developer from Oxford University or something. One of those places. There was maybe a Harvard in England campus. I'm not exactly sure, but he created BCPL, and he was definitely British. And BCPL inspired Dennis Ritchie to do the C language, which Unix was eventually ported over to because it was originally written in BCPL, because it created this virtual machine like some system. It wasn't really virtual machines. You can't give credit to BCPL and C for fully doing what Java did years later. but you can give it most of the credit, because the fact that anything written for C would compile on anything that had the C compiler ported to it was the magic 1-2 combo that birthed the digital revolution. That was the digital electronics revolution, because before then you did not have a suitable host for the TCP/IP operating system. So when TCP/IP came along from Vint Cerf and I guess the ARPANET endeavor, the endeavor to make a computer network that could route around an atomic blast, they said, oh, well, we need a very generic computer operating system to host the TCP/IP networking stack. Well, that thing called Berkeley System Distribution looks like it should be it. So UNIX and TCP/IP came together, but it was weighed down with intellectual property issues. So Linus Torvalds made his project making a 386 Unix-like operating system, where he violated many of the rules that made Unix Unix. It was not tightly regulated by some centralized authority. Linus was saying, hey, not only can anybody use this however they like, but if you use it for commercial gain, you have to give your contributions back to the community, which is where the Open WRT router project came from. And that blue router that I showed you at some point during my move. I wish I was more into that kind of hacking stuff, because there was some really interesting mesh networking stuff made possible in the early days. If only you knew how to program low-level network stack stuff for Open WRT and those routers. And that company was later bought by Cisco, so Linksys got gobbled up by Cisco. But Linus Torvalds, in addition to using the GPL and eventually the GPL2 license that forced that giving back, he also said, no, I'm going to make things just work as well as they can on that hardware. So the Linux kernel became a large object, a very large object, having a lot of responsibility for different things going on inside of itself, like the division of user space from system space. It was not as clearly divided as it would be in the microkernel design of Minix, and thus there were, there's security concerns with Linux all the time, surface area, worries. Are there bugs still lurking, zero-day exploit things, because you can't yank out whole functional subsystems of Linux with portions of it being tightly coupled as they are. Okay, and so that's why Linux is so hard to port to all these different ARM platforms. Everyone is a work of art, and so, people have to move in and create virtualization layers. This Cortex, thing, the ARM Cortex design creates virtualization layers so you can do this hypervisor stuff so that you can have scalable ARM, so they did a lot of the tricks, but you would have to abide by their design. And if you want the advantages of being an ARM licensee, then you just do it yourself your own way. You create your own Cortex. And I believe that's what Apple did. And so Apple uses the old Acorn design. ARM came from a Commodore-like computer company from the UK called Acorn. And their processor designs were very RISC-like and very appropriate for low-power environments. So after their home computer, the Acorn, failed, Acorn Archimedes, maybe. There were some interesting Amiga-like computers there from that company. But after it failed, they salvaged the CPU intellectual property bit, because they had designed their own processors, by creating the ARM holding company that just licensed out ARM processor designs, machine instruction sets and stuff. So the fact that every ARM processor is kind of sort of a work of art. That's why there's no standardized laptop motherboards. Every laptop is a work of art. And so if it's an ARM laptop, only doubly so, work of art. So this creates a compatibility challenge, because all these works of arts can be utilized to their fullest with all their customized software, customized operating system extensions, customized API hooks, ways to hit the metal through, formal and informal means. And because there's like an industry pressure now to have ARM do the same thing as x86 hardware, which is to make me not have to worry about all of that stuff, to make my drivers just port easily, at most a C recompile, but why should I even have to recompile for C if it's also 64-bit ARM? Isn't 64-bit ARM everywhere, be it on a Mac, Windows, or Linux? Well, the answer is yes. Eventually that is where everything is going. They're going to be Unix-like binaries. How could it not be? It is my firm belief that Windows as we know it is going away, and no one will know it. It won't even be noticed, because step one, Windows subsystem for Linux, have it easy to install a Linux terminal. I cannot emphasize enough, it's a Linux terminal. It's a text-based way of interacting with a Unix-like operating system. Happens to be Linux, but it's Unix-like enough that, well, two things. One, you embrace all the good parts of Unix. But two, because it's Linux, you have systemd, another controversial monolithic piece that's been dropped in on the Linux side, very reminiscent of the Linux kernel itself. So the Linux kernel is accused of violating the Unix way because it's large and does everything. Systemd is a system manager, manages a whole bunch of privileged operating system tasks that were previously managed other ways. It wasn't like this stuff wasn't managed. It was managed in a kludged together, extremely Linux-like, Unix-like way with bash files. So a flavored Unix, a bash-flavored Unix-like way. So you had all these files everywhere for starting and stopping services that if you looked at them, there were these long bash scripts. And that was the init.d, or the init system for doing this, because, Unix is really not much more than, a bunch of commands and then dropping a bunch of text files places that use those commands. That's everything. That's what Steve Jobs hated. Oh my God. So all the stuff I'm advocating is really all the stuff that Steve Jobs hated and, tried to change in creating a computer revolution with a desktop revolution, with a Macintosh, changing expectations, with point-and-click operating systems. It arguably set computing back by decades. To consumeritize computers while making them more friendly $2,000 game machines also diminished the still giving gift of the language-based portion. The command line interface is language, spoken language-based, written language-based, precise, easily codified, naturally sequential, sensible, readable like a story top to bottom. When turned into functions and no longer readable top to bottom, still readable in some way. You can still follow it. Text is a wonderful way of controlling machines. I'm starting to get a little disheartened here with all the traffic I hit. I did not think I was going to be hitting traffic like this on a Tuesday night, driving out into the mountains. What kind of traffic is this? And it's a standstill too, on the highway. I'm probably behind an accident. I'm not far from where I'm going, but this last bit could take much longer than I expected. This video is at an hour and a half, and usually this whole thing is an hour and a half ride. Yeah, I'm definitely behind an accident. Shoot. Well, all the more talking for you. Recenter. What we do is we bring ourselves back to a neutral state where we're like a needle hung in the balance. We could go different directions, and then our wandering mind, the residual from our previous thoughts, will push us in the direction we need to go to get back to where we were talking about, which was, of course, operating systems, and the difference between pure, the UNIX way, which is inspiring, which is a good standard to hold things up to, and the way things really actually become on the Linux side, which is monolithic kernel for the Linux kernel, which is a monolithic system manager in systemd, something that manages all the tasks that need to be running in the background, how things are broken up. I believe it handles the privacy of separating, user space from system space, and how networks can access things, right? Because there's bridges between these spaces. The rules governing all this stuff is really quite important. It's something in need of formalization in order to be as good as the proprietary stuff. Systemd falls under the category of things that need to be done so that the free and open source community and the world can offer services as top-notch as proprietary systems. Rarely are things pushed forward so aggressively at this low machine, tied to the machine. All this stuff is tied more to the machine than you might imagine, tied more to the actual hardware implementation. Now, thankfully, there's these thunking layers, so it's tied to like an x86 64-bit or 30. There's a further qualification. What bus size is it designed for? More and more often it's designed for 64-bit, but now it's x86 64-bit, and then there's ARM 64-bit. So each one of these would have to have a different executable file, a different .exe, although they're not .exes on anything but PCs. But a lot of us know executable files as .exes. So those have intimate knowledge of the hardware they're running on. They are EXEs because they get dropped in a certain location in memory and a state is recovered almost instantly, because the compiling process to create that EXE has deep, intimate knowledge of the hardware, the target hardware. So EXEs are optimized. They're high performance. They're usually static in nature. They don't use things like Python dynamic lists inside of them, or else it would have to keep portions of it uncompiled, not turned into machine code yet. It would have to be in a sort of in-between state. So there's all kinds of tricks to get high performance out of Python. Sometimes you program your bits of it in C, and then it's CPU bound. It's so interesting, the give and the takes. Now, all these discussions lead to GIL, doesn't it? I'm not even going to talk about the GIL. Python is an 80-20 rule language. You get 80% of the benefit from the first 20% of the effort. If someone can figure out how to remove the global interpreter lock, Guido van Rossum, who is no longer the benevolent dictator, but now presumably the Python governing board, would be open to the removal of this global interpreter lock that Python continues to have in its main reference executable interpreter, Python evaluation engine. Most of it exists in the code for the eval command. If you wanted to look at this stuff, you would just look at the C code for Python, for CPython in GitHub. Oh, this is painful, this traffic. If I knew I'd be hitting this traffic, I would not be doing this tonight. But you roll with the punches. This is more of what it is to be human. He says as the camera falls, it's still recording. Oh my goodness. How is that even possible? That's not gonna hold now. Ugh. Is it still shooting? Oh, gonna be for the true hardcores who stay with me through this. Accompanying me in traffic. I feel like I want to just flip on an Audible now. And so I shall. I'll talk to you folks later.